recording. All right, here I have an example. It looks like it was 1/4 sine theta plus 1 equals 0. And if you have a question like this, which I'm not sure if this was on maybe the do now, I think, Adar, I think you actually asked me about this one, if I remember correctly.
Yeah,
It was a do now one, a warm up question, or a homework. I think it was do now, right?
it was a do now.
Okay, thanks. So we're going to solve for theta. So I'm going to start off, I'm going to subtract 1 from both sides. Classic. 1/4 sine theta equals -1. Now, we still have to try to get theta alone. How do I get theta alone? I'm going to multiply both sides. What do you think we should multiply both sides by to get rid of a 1/4? We would multiply by the number 4, the reciprocal. So the reciprocal is what will multiply to give you a 1 to get rid of something. We don't always multiply by reciprocals. I know sometimes I ask like, oh, how do you get rid of your fractions? People are like, oh, let's multiply by the reciprocal. You can multiply by the least common denominator in that case, but that's a separate story. 4 1/4 is adios. We are only left with sine theta because it's an invisible 1 in front. And now I have -4. So here's the dilemma. When you have this, what you have to remember is first and foremost, nowhere on my unit circle does sine equal -4. On my unit circle, sine equals 0, sine equals 1/2, -1/2, √2/2, or -√2/2, √3/2, -√3/2, 1, and -1. I never see it equal -4. That doesn't mean it cannot equal -4 just because it's not on the unit circle. However, think way back. The thing that sine of theta is equal to is actually a representation of a ratio, opposite over hypotenuse. So if I have -4, that would really mean -4 to 1 is my ratio of opposite over hypotenuse. But what do we know about a hypotenuse in a triangle? The hypotenuse is always the longest side. Your opposite and your adjacent, because this is right triangle trigonometry that SOHCAHTOA and sine, cosine, tangent all stem from. The right triangle trigonometry, SOHCAHTOA, the hypotenuse is always the largest side. It's always a right triangle. And your opposite, if this is theta, then this is your opposite side. This was your adjacent side, depending, every picture is different. That's your hypotenuse. Well, that's impossible. How could my opposite side be -4, down 4, if my hypotenuse is only 1? If you think about that, it wouldn't connect. You would have a sad right triangle, like I'm a failure of a triangle. That's 1 unit, okay? And then over here, your opposite needs to be 1, 2, 3, 4 units. But this, the adjacent needs to make a right angle. And this guy's like, I'm trying. It's like a T-Rex, its arm can't reach. So what does that tell you about this theta, this angle? Not possible. So what would happen here? No solution. Okay? So if that ever happens, if your sine or your cosine is a ratio where your opposite is bigger than your hypotenuse or your adjacent is bigger than your hypotenuse, ignoring the negative. The negative either means down for sine or left for cosine, but ignoring that. If it's that, then you can't get an angle, no solution. Similarly, sidebar, bonus, if you got a question like this, cosecant theta equals -1/4. Same idea, no solution. Because cosecant is the reciprocal of sine, so that would be hypotenuse over opposite, and it still doesn't make sense. Okay? So that would still be a no solution. So that's the end of this example right over here, 1/4 sine theta plus 1. Basically, this applies for all examples of sine, cosine, secant, and cosecant, where sine, since it's opposite over hypotenuse, the opposite cannot be bigger than the hypotenuse. And then vice versa, cosecant and secant, since it's hypotenuse over opposite or hypotenuse over adjacent, the opposite or the adjacent cannot be bigger than the hypotenuse. We don't have this issue with tangent and cotangent because it's opposite and adjacent, and anybody could be bigger or smaller. So tangent, cotangent, anything goes. So I hope that makes sense. Makes sense. You document that in your brain. You don't need to ever look at it again. Thumbs up. If you're like, maybe I should look at this again, put a thumbs down so you know it requires more of your attention. Okay.